In this video I will demonstrate how to generate turbulence files using MultiSetup. Begin by setting up the wind turbulence calculation in Bladed. The Kaimal model is the most simple model to set up. The base model is now defined. We will use MultiSetup to define variations. We would like to generate wind files with different mean wind speeds. So let's add mean wind speed as the parameter to vary. Let's vary the wind speed between 2 and 25 with a step of 2. For each wind speed we would like to generate 6 wind files, each with a different turbulence seed. Use a mapping to set up this behaviour. We can use the mapping generator to generate these. We can use them seeds. There are two options here, random numbers or sequence. Let's use a sequence to begin with. So what we're saying is we would like 6 seeds for each mean wind speed, and we'll start at the seed of 0, generate. Here we have 6 seeds per wind speed. The Kaimal model only requires definition of the mean wind speed and the seed. Let's name the resulting files wind underscore and then use the number, the seed number. Let's put the files in a folder named by the wind speed. That completes setting up Kaimal wind files. This could now be added to batch. Let's now have a look at setting up the improved Von-Karman model. In the wind dialog, choose the improved Von-Karman model. Here we have a similar situation with wind speeds defined between 10 and 14 with a step 2, and for each wind speed we're asking for 6 turbulent seeds. Now with the improved Von-Karman model we need to set up some more parameters. The improved Von-Karman wind model requires roughness length to be specified. Roughness length is normally calculated from longitudinal turbulence intensity. Longitudinal turbulence intensity can be specified directly if you have site-specific data. Alternatively, the design standard specifies a relationship between mean wind speed and longitudinal turbulence intensity. MultiSetup supports calculating these values automatically based on the relationships in the design standards. Several combinations of design standards and turbulence models are offered. Let's choose IEC Edition 3 Extreme Turbulence. The input parameters to this calculation can be customized. Now that we have defined longitudinal turbulence intensity, roughness length is automatically calculated. This concludes setting up improved Von-Karman wind files. These can now be added to the batch. Finally, let us consider setting up non-improved Von-Karman turbulence files. The special case here is the need to define the 9 components of turbulence length scale for each wind speed. We've chosen the turbulence model. Now in MultiSetup, let us define the length scales. So as before, we have a range of speeds defined, and for each speed some turbulence seeds defined. In the parameters tree you will find the 9 length scales. These can be added to the setup and specified using mappings. So choose a mapping to mean wind speed, and then paste values into this table. Repeat this for each of the 9 components. Here you can see all of the tables have been filled in with data pasted from a spreadsheet, and if we look at the summary table, these are fictitious values, of course. You can see that for each wind speed the appropriate length scales have been used. These can now be added to batch. And that concludes the tutorial video on generating turbulence files.